welcome to another exciting series. Now in this one, we'll be learning about composable functional JavaScript. We'll be starting with how to unnest function calls, capture assignment, and create a linear data flow with the type we will be calling as box. So over here, you can see that we have a function, next char for number string, and this is doing certain set of operations. First, it's trimming the string that we have passed, then it's converting it to a number and then adding 1 to it to get the next number and then providing the ASCII value of it. So from char code, we pass this next number as the input, and over here you can see we are getting the output as B, and that's what we have over here in our console log as well. Now the point of this function is not the actual functionality. If you look at each of these lines, they're doing different things. We have a method call over here, we have a function call here, an operator, and then a qualified class function. As you can see over here, we want to unify it all and compose it in one linear workflow instead of separate lines with lots of assignment and state as we go along. How can we do this? We comment this whole thing over here and let's rewrite this in a new way. One thing we can do is we'll try to compose this up in one big expression functionality. So here we'll have this string dot from char code, and as we can see that this is expecting a next number, and that next number needs to be trimmed first, converted to a number. So what we'll do is we will be passing parse int over here, and within that parse int we will be providing the str.trim. And once we have trimmed this, the parse int will take place, and then we can go ahead and add 1 to it. Now this is also going to return the same result. So here, if I take this line and on the next line, I go ahead and call this function, save this and reload it, you'll again notice that the output still remains the same as B. But let's explore this, what exactly we have done over here. If you see, it's very confusing to begin with. It's going to work, as you have seen, the output is still the same. If we look at the control flow here, it's totally bogus. It's one big expression. It's clean but hard to follow. It jumps all around here, trimming, parsing, and adding 1 over there. Now, what we can do is we can make it more readable to begin with, and we'll try to make it self-explanatory as well. So we'll be borrowing a trick from our friend array. The first thing that we can do is, so let's comment out this as well, and over here we'll be taking this line and starting a new function. What we'll be doing now is we'll be converting it as an array. So here we have boxed it inside rectangular brackets. Once we have this box around the string, we are now having access to certain methods that the array provide. As you can see over here, it's suggesting as well that we can make use of map s.trim, and similarly I can go ahead and make use of further map functions to generate the same output. Let's go ahead and do that. So now I can go ahead and do this as well, map, and within this I can have parse int. So I'll say parse int, and then this is now converted to a integer. After that, what I need to do is add 1 to that number. So that is also done now. Next, what we have to do is apply this class method, string dot from char code. So let's go ahead and do that as well. So I'll say map, and over here string dot from char code, and within that I can pass the I. Now we have everything over here. If I go ahead and save this and run it now, we are getting B inside an array, or we can call B in a box. So what exactly is happening over here? We have captured each assignment in a very minimal context. Now this S cannot be used outside of this little function in map. Despite calling it the same point is, each expression that we have over here has its own state completely contained. We can break up our workflow and go top to bottom, doing one thing at a time, composing together. That's the key. Map is composition because it takes input to output and passes it along to the next map. And we are composing this way. Now, let's see what else we can do here. Instead of this array with a bunch of maps on it, why don't we make this a little bit more formal? So let's go ahead and create a type, and we'll be calling it a box. So we'll say const box, and this is going to take a single argument. So the argument, we call it as x over here. After that, we'll have our object literal with methods. So this is what we will have inside our box. As you can see, with this box, we were able to make use of map method. So we'll have a map method over here as well. Let's go ahead and create one map. So the map method takes a function, we call it that function as f over here, and applies it to the wrapped value. So how we can apply it to the wrapped value? Let's call it as box and then f of x. So the function f that the map method takes, and then it applies it to the wrapped value x by creating a new box with the result of fx. That's what we have over here. This is a common functional programming pattern where you transform the value inside a container while keeping the container structure intact. And we'll also add one more over here. We'll call it as inspect so that we can have it in the log. So it's just going to print the value of x as box. Now let's rewrite this function that we have. So instead of this box str, we'll be actually writing as box str. Now we have the box str over here, we have the map method, and let's go ahead and check it out now. So here, if I run this over here, you can see when I'm exploring this map and inspect, you can see the value over here, box xb. So the result is definitely coming up, but it's not coming up the way we want it. So what we can do over here is introduce one more function, and we call this function fold, and this time this is exactly what map is doing, but one less step over here. So instead of wrapping it within a box, we are just folding it. So we'll say fold, and finally what we'll do is we'll make use of this fold on a new line. So here we'll say fold, and let's try printing this c dot to lowercase over here. Save it now, and let's run this one more time. Now you can see the output coming up as b over here. So let's understand what we have done on this line, fold. Now the fold method over here, as you can see, takes the function f and applies it to the wrapped value x directly. It's a way to extract the value from the box and apply a function to it. This is also known as unboxing in functional programming. If I don't want the lowercase, I can just go ahead and remove this, save it, and there we go. We have the capital letter B coming up as the output. So the box that we have over here in functional programming terminology, it's basically an identity factor. So we've learned how to unnest function calls, capture assignment, and create a linear data flow with our identity factor called box.